Okay, this lesson is about plotting graphs from linear equations, and we will do that from both the slope-intercept form of the equation and also the standard form. We'll do a couple of examples of each, showing a couple of different ways to look at it, and I'm just going to start from scratch on a graph, and we'll just make up some equations and work through it. The first graph we'll do, let's do a slope-intercept form equation, and we will use in this first plot, we'll just use the information that's right there in the equation, the y-intercept and the slope, and work from there. So let's take an equation like y equals 2x minus 4. And we're going to plot that equation. Now, the first thing is, remember that this is the slope-intercept form. So we have our slope value right here at 2, right? And we have our y-intercept. Okay, so first thing let's do is just go ahead and plot the y-intercept. That's easy. And we'll use each blue box on our graph as signifying 1, so that like this will be 2, 4, 6, and so forth. 2, 4, 6, and then of course going back the negative direction. Okay. All right, so what do we got? So the intercept is at minus 4. So let me scroll down a little bit here. Minus 4. So minus 4, that means that the y-intercept then is, like again, remembering that if we plug in 0 for x, we will have y equals minus 4, so our y-intercept then is, and I'll go ahead and go into greater detail here, but y-intercept then would be 0 minus 4, okay? So we'll plot that, okay? And so let me change color here for this. So this would be right here, down here at 0 minus 4, and then the slope is 2, right? So what does that mean? Rise over run, right? So we can go up 2 and over 1. So let's just start there from our y-intercept. So we go up 2 and over 1, up 2 and over 1. We can do this 2 or 3 times until we're comfortable. We can draw a nice straight line through the parts, right? And so there's several points that we can draw. And then let's take our line here and take it and just draw it down through the points. And it looks like I'm pretty close, but not totally close. So let me see. Yeah, tap this and get our thing on here. Go through these points a little bit better. Okay, and there you have it. Okay, so there's our line through those points. And what we might want to do, going back to our discussion of domain and range and being accurate about this graph, we have no real reason to believe that this graph is ever going to stop. Because we haven't restricted it in any way, so we would go ahead and put our arrows on the 2 ends to indicate that it keeps on going in both directions. Okay. Now the other thing we can do with the slope-intercept form, and we can just, let's take a different equation this time. That one had a positive slope and a y-intercept that was negative. Let's take another one that has a negative slope. Let's do y equals negative 1/2 x plus let's say 4. Okay, so here's a case where we're going to do the intercepts instead. Now this is very easy to do the same way. In fact, I guess what I'll do is I'll do both ways here, and we'll just start the same way. We know our y-intercept is going to be at 0, 4, because we plug 0 in for x, we get 4. So our y-intercept is going to be right here, okay? And we have a slope of a negative 1/2. So what we got is a negative rise over run, which means we're going downhill from left to right. And so we're going to go down 1 and over 2, down 1 and over 2, down 1 and over 2. And we've done that the same way. And then we can draw our line over through those points, okay? And let's see, we'll do that, and we'll hit that, and then we'll come down a little bit. And that's pretty close, okay? So there's that one. But let's look at this a different way. Suppose that we didn't want to do it that way and we wanted to use the X and Y intercepts or something like that. There's a couple things we can do. Linear equations really are so simple to graph using either slope-intercept or using the Y and X-intercept. But let's suppose that we wanted to know in advance where the X-intercept was, and we could use the Y-intercept and the X-intercept. Well, first of all, let's go ahead and write down the fact that we calculated our Y-intercept at 0, 4, right? Now, what about the X-intercept? And we did this once in another lesson on X and Y intercepts. But let's do it again here now that we're using it specifically to plot. So for the X-intercept, what do? Remember, we let Y equal 0, right? And then we calculate X. So let's plug in Y equals 0 into this equation right here. And so what we'll have is we'll have 0 equals minus 1/2 X plus 4. Okay? And so what are we going to do to do this? We've got to solve for X, right? So the first thing we're going to do is we're going to subtract 4 from both sides. Okay? And so this becomes minus 4 over here. And what do we get? We get minus 4 equals minus 1/2 X. Now, what do we have to do to find X? What do we have to multiply by or divide by to find X? Well, if we multiply both sides of the equation by 2, or minus 2, really, minus 2 times minus 1/2, that's minus 1/2 of minus 2, which is just 1. So what we can do is we can actually just multiply this equation, and let's go ahead and multiply this equation by minus 2. And so what do we get? We get minus 2 times minus 4 is 8 equals, and minus 2 times minus 1/2 gives us 1 equals X, right? So then our X-intercept becomes 8, 0. Remember, we plugged in Y, okay, and then we calculated for what value of X makes that true. And so our X-intercept is 8, 0. Well, 8, 0, let's see, 2, 4, 6, 8 is right here. And guess what? If we were to extend this line that we've already plotted, we could plot the X-intercept and the Y-intercept. Whoops, let me do this first. Make this nice and clear. That would have been the Y-intercept. This is the X-intercept. And then if we just take the line that we had here and extend it down through there, we would be at the same place. Okay, two different ways of looking at that. Now, ultimately, and I'm not going to cover this here, I don't think, because I don't think it's really necessary. But if you really had to, you could do an XY table. Okay, you could say, okay, here's my equation: Y equals minus 1/2 X plus 4, and I could just say, okay, let's pick out some values of X and calculate what Y would be, right? So if I'd put in, say, minus 2 for X, plug it in up here, I'd have minus 1/2 times minus 2, which is 1 plus 4, and that would give me 5, right? And then if I plugged in minus 1 for X up here, I would get a plus 1 here, plus 1/2, and then I'd get plus 1/2 plus 4 is 4.5 here. And then if I plug in 0, I'd get 0 for X. I would get 4, which we already saw with the Y-intercept, right? And so forth, 1, 2. And I could plug those values into the equation. But since we're working with a straight line equation, it's really simpler, I think, just to go ahead and use either your slope and your intercept, like we did in the first go through here, or if you really wanted to calculate the X and the Y intercepts, we could do that and plot those. You'll get the same result in any case that we do. Okay. All right, so let me scroll down here. Let's take a look at plotting a graph from the standard equation. And let's just make up one here. Remember, standard equation is in the form of AX plus BY equals C. And let's do 2x plus 3y equals 6. Okay. All right, and so remember on this one, a couple ways we can go. We can do the y and x-intercept, right? So y-intercept, we set x equals 0, remember? X equals 0, so if we set x equal to 0, we will get 0 plus 3y equals 6. And so therefore 3y equals 6 or y equals 2, right? So our y-intercept then is at 0 for x and 2 for y. We can plot that right there, right? 0, 2. And then if we want to know the x-intercept, we would do x-intercept. That occurs when y equals 0, right? And so when we plug y equals 0, we'll get 2x plus 3 times 0, which is 0 equals 6. Divide both sides by 2, and we get x equals 3. And so our x-intercept then is 3, 0. Calculated value of x when y equals 0. And so 3, 0 is going to be 1, 2, 3, 0 right here. And we can do the same thing. We go ahead and plot a nice little line, okay, through those 2 points. Okay, clean it up a little bit. And there's our line, okay? There's our line. And as you can see, we have a negative slope in this case, and it goes through those intercepts. Now, what if we wanted to calculate the slope? Remember, in the video on finding intercepts, I think, show you how to shortcut, just as a sideline, of calculating the slope. And this was a little thing I gave you as a shortcut to check things. So like I said, that if for a standard form equation, slope equals minus a over b, which in this case is minus 2 over 3, and that's what the slope is. Okay, if we look at our slope here, we're going to go down 2, minus 2, and over 3. Okay, 1, 2, 3 over here is the run. Rise over run, negative 2 over 3. And so we calculate our slope. So even with the standard equation, if we wanted to use the y-intercept or the x-intercept for that matter and use the slope from there, we can calculate the slope with minus a over b. And again, it's a little bit more difficult, but you could in fact do an xy table. I wouldn't recommend it for this form of the equation, or if you wanted to convert from the standard form to the slope-intercept form, you could do that. But it's really not necessary because it's so easy to calculate your y-intercept and your x-intercept and just draw the line between those two. Just be careful, as always, about your math and your minus signs. Okay, so that's plotting a graph with the standard form and the slope-intercept form.